Hi friends, good morning. Today we are going to discuss about representation of Fourier series in different formats. Okay, see, we can represent the Fourier series in terms of omega, time period, and also we can represent in length or x. This kind of variable all are we can represent the Fourier series. Okay, see, suppose our expression for Fourier series generally we have studied as that is a function, a periodic function f of x is equal to a0 by 2 plus sigma n is equal to 1 to infinity an cos nx plus sigma n is equal to 1 to infinity an sin nx, right? So this is the Fourier series expansion. This we can represent over a time period also. Okay, see, so x is equal to pi. So suppose you are considering a sine function. Okay, so here it is 0, here pi by 2, here pi, here 3 pi by 2, here 2 pi. So this 2 pi corresponding to a time period, right? So this pi corresponding to t by 2, right? So x is equal to pi corresponds to t is equal to t by 2. So the same Fourier series expansion that I can represent it over a period also. Okay, see. So x is equal to minus pi to pi means integral minus pi to pi, the integration we can take that as minus t by 2 to t by 2. So we have generally studied this a0 as 1 by pi into minus pi to pi f of x dx. Okay, so that I can represent the same expression I can replace as a0 is equal to 1 by pi minus pi to pi f of x dx, right? So here if x I am replacing with the time format, then a0 is equal to this pi corresponding to t by 2. So t by 2 integral minus t by 2 to t by 2 f of t dt, right? So I can replace this like this. So similarly we can an cos nx. Okay, see, an cos nx, that is 2 by t integral minus t by 2 f of t into cos nx dx, that also I can replace as 2 pi by t. Okay, 2 pi by t. Okay, in terms of time period. Okay, and also here bn also we can represent as 2 by t integral minus t by 2 to t by 2 f of t sin 2 n pi by t. And also again this you can convert into in terms of omega. How can we represent? So omega is the angular velocity that we can over a period we can call it as it is 2 pi. Okay, omega is equal to generally theta by t. Okay, if I am considering over a period, then this theta is 2 pi and corresponding time taken is time period. So I can represent this omega I can write as 2 pi by t. So I can replace this omega as this 2 pi by t. Okay, so here n omega t, right? So t all we will change. Okay, that is t is equal to 2 pi by omega. Okay, then what is t by 2? That is pi by omega. Okay, so the same expression I can represent as a0 is equal to, so I can write this as t by 2, right? This 2 by t I can write as, instead of t by 2 I can write as uh, that is pi by omega, right? Pi by omega integral minus pi by omega to plus pi by omega. Okay, into f of omega d omega. Okay, so this is our a0. Similarly, an I can represent as again the same 1 by pi omega into minus pi omega to pi omega, right? This is f of omega cos omega t dt. Okay, cos omega t dt. Okay. Similarly, we can represent bn also. Okay. So we can represent our function Fourier series expansion of a periodic function in different variable formats. Okay. Okay, so when we do a problem, you will get more idea. See here also you can see f of t you can represent. Okay, so if you consider 2 pi by omega is capital T. Okay, that is over a period 0 to t I can represent like this also. That is a0 by 2 sigma n is equal to 1 to infinity as an cos n omega t plus bn sin n omega t. Okay. Now here a0 is equal to omega by pi integral 0 to 2 pi by omega f of t dt, and an is equal to omega by pi integral 0 to 2 pi by omega f of t cos n omega t dt, and bn is equal to omega by pi integral 0 to 2 pi by omega f of t sin n omega t dt. So sometime we can represent this instead of representing 2 pi by omega. So this I can represent as minus pi by omega to pi by omega also, because the difference this range is pi by omega minus pi by omega, that is 2 pi by omega. Okay, so this I can write as minus pi by omega to pi by omega based on the situation. Okay, based on the situation, sometime the function is defined in the interval minus pi by omega t less than pi by omega. Then you can use like this. If the function is defined 0 less than equal to t less than or equal to 2 pi by omega. Okay, so we can represent as per the interval we can split this interval into different formats. Okay, sometimes they will give the function split into two parts that will be equal to 0 in the interval 0 to less than t less than pi by omega, and then they will give another interval. Okay, that is its function's value is t in the interval that is minus pi by omega. So here minus pi by omega less than t less than 0, and here 0 less than t less than pi by omega. Okay, so you can split this particular integral into two parts, minus pi by omega to 0 plus 0 to pi by omega, and we can give the function's value in the appropriate intervals. This all we can do. Okay, so this all about the various kind of representation. Okay, so f of t I can represent like this. Yes, here it is given. I can represent this as minus pi by omega to minus pi by omega pi by omega, as I have said earlier. Okay, so these all are these different kind of representation. Now we can do a problem based on this. Okay, given f of x is equal to x plus x square for minus pi less than x less than pi, find the Fourier expression of f of x and reduce this expression. Pi square by 6 is equal to 1 plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square. Okay, so as usual we can find out a0. Okay, what is a0? a0 is equal to 1 by pi minus pi to pi f of x dx, that is 1 by pi minus pi to pi x plus x square dx. F of x is given in the question, and also interval is given, so we need not to split into two intervals because minus pi to pi. So as our usual expression also, that is defined in minus pi to pi. So you can directly give the substitution, and when I am integrating x, that is x square by 2, x square on integrating x cube by 3, so 1 by pi into minus pi to pi. Now I am giving upper limit, that is pi square by 2, this is pi cube by 3, minus lower limit, that is minus pi square by 2, that is minus pi square by 2, minus of minus pi cube by 3, that is plus pi cube by 3, then you will get 2 pi square by 3. Okay, now let us calculate an is equal to 1 by pi minus pi to pi f of x dx. Okay, cos n x dx, that is integral minus pi to pi. What is f of x? F of x is x plus x square dx, x plus x square into cos n x dx, that is our an constant. Once you get a0, an and bn, then you can substitute in the Fourier series expression. Okay, then when I am substituting the values of f of x in the an expression, then I will get this an value is 4 minus 1 raised to n by n square. So the derivation is not given here, so let me derive this. So let me write this integral minus pi to pi x plus x square cos nx dx. Okay, cos nx dx. Okay, so this we need to solve. So let me go to the blackboard. Okay, so this is equal to an. So we are focusing on finding an. Okay, so that is, so I can substitute the value, that is 1 by pi. So I can apply parts to integrate. So 1 by pi, for an we have a 1 by pi here, right? So 1 by pi into, so first function into, that is x plus x square into integral of second, that is sin nx by n. Okay, sin nx by n minus differential of first, that is 2x plus 1 into integral of second again sin nx by n whole dx. Okay, now I can expand this, that is 1 by pi into x plus x square into sin nx by n, right? Now here I can take this minus 1 by n out, and I can integrate this again using parts. So I am keeping a bracket here. Okay, that is first function into 2x plus 1 into, when I am integrating this sin nx, I will have minus cos nx by n minus differential of this 2x plus 1, that is 2 into, and integral of this sin nx, that is again minus cos nx by n into dx, right? Now this I can write as x plus x square into 1 by pi out. Okay, I am expanding the bracket, sin nx by n. Okay, now I can expand this bracket, minus minus plus, that is 1 by n square into 2x plus 1 into cos nx, right? Cos nx minus, so here we have minus and again minus and again minus. So we have 3 minus sign here. So and this cos nx on integration, we have again sin nx by n. So here n here we have one more n here. So n square n cube. So I can write this as minus 2 by n cube sin nx, right? So our integration process is over now. Now let me substitute the limits minus pi to pi. So when I am substituting the limit, see minus pi to pi, the sine component all will be 0, because this sine pi and sine minus pi, that all are sine n pi and sine minus n pi, that all are 0. Okay, so the only term exists here, it is this term. Okay, so I can write the pi value here. So 1 by n square into, outside I have a 1 by pi, and this term is 0 and this term is 0. So here when I am substituting the values, that is 2 pi plus 1 into cos n pi, right? Cos n pi, and when I am giving minus pi here, this term will become, so minus of upper limit minus lower limit, that is again this 1 by n square into, okay, so I can give a bracket like this, minus 2 pi plus 1 into cos of minus pi, that is cos pi. Okay, so again cos n pi. Okay, cos n pi. So we have substituted the values, and now we are expanding this. Okay, so I have these terms only, this minus minus plus. Okay, so this term will be add up and remaining whole term will be 0, because here minus. Okay, so by expanding, so we will get, that is for 1 by pi into outside 1 by pi. Here this term doubles, because here minus of minus. So 4 pi by n square into cos n pi. Okay, cos n pi is minus 1 raised to n. So this pi cancel. So I can write the result as 4 into minus 1 raised to n by n square. So this is our an value. Okay, once you get an value, then we can do solve bn value. Okay, so let me come to the main board. So here we have solved the an value, that is 4 minus 1 raised to n divided by n square. Okay, now similarly we can solve this bn. What is bn? Bn also we can solve. Bn is equal to 1 by pi. So let me go to the blackboard again. So 1 by pi bn is equal to 1 by pi minus pi to pi f of x. That is f of x, we know that is x plus x square. Okay, x plus x square into sin nx dx. Okay, sin nx dx. Now let me go to the blackboard again. Okay, so when I am doing this with partial parts, okay, so 1 by pi into, so what is our first function? That is x plus x square, and when I am doing the sin nx, I will have minus cos nx by n and minus of integral d by dx of x plus x square, that is 2x plus 1, that is 2x plus 1 into minus cos nx by n dx. Okay, now again we can integrate and finally we can give the limit, that is bn is equal to, so 1 by pi into 1 by pi into, okay, so I can substitute this limit x plus x square. I can integrate the second part also. Okay, cos nx by n, right, minus, okay, minus this minus minus become plus, right? So and I can take this 1 by n out, and if I am integrating the term again using parts, okay, not 1 by n square, it is 1 by n. Again integrating, what I can write 2x plus 1 into first function into integral of second, again sin nx by n, right, minus 2x plus 1 on differentiation, I will get 2 into this sin, this cos nx on doing, again sin nx by n, right, into dx. Okay, now if I am substituting all the values here, again I can write this 1 by pi minus x plus x square cos nx by n, right? So if I can expand this, what I can write, that is 1 by n square 2x plus 1 sin nx. Okay, now if I am expanding this sin nx by integrating this sin nx by n again, so I will get cos nx, right? And here cos nx by n, so here cos nx by n square and minus, here we have a minus cos nx and here we have a minus, so totally the term will be plus, that is 2 by n cube cos nx, right? Our limit is minus pi to pi, right? See here this term, so here this term only will exist because when I am giving the upper limit, so bn is equal to 1 by pi into upper limit, what I can write, minus of this pi plus pi square. Okay, pi plus pi square, all x I am replacing with this upper limit pi plus pi square, and here cos n pi, right, cos n pi by n, cos n pi by n, and minus lower limit, minus lower limit, okay, minus lower limit, that is I can give minus pi, that is minus of, so the function itself has a minus, so minus pi cos nx minus pi whole square, that is pi square itself, cos negative pi, cos of minus theta is cos theta, so again I can write cos n pi by n here. Okay, and when I am substituting here, this is sin pi and minus upper limit minus lower limit for the second term, that will be 0 because sin n pi is 0, sin minus n pi is also 0. Here also when I am substituting, there is no variable in the outside, so cos n pi minus cos n minus pi, cos of minus theta is cos theta, so this term also upper limit minus lower limit will be 0. So only term exists is this. Out of this, here you have minus minus, right? Here you have minus minus, that is plus, so this is plus minus, and here minus. Okay, so the first term only will exist, the pi square and minus pi square, that will cancel out. So the remaining term is 1 by pi into what I can write, that is minus 1 plus here I can take a pi out, right? So the remaining term is pi into, so double the term, that is 2 into pi into, okay, 2 into pi into, so here pi, and the common term is cos n pi by n, cos n pi by n, right? And also we have a minus here, right? Why? Because this is minus pi cos n pi by n. This also when I am multiplying 3 minus sign here, so minus cos n pi, so minus plus minus, there is a negative sign. Okay, so this I can pi cancel, so this I can write as minus 2 by n, cos n pi is minus 1 raised to n. So this is the expression for bn value. Okay, now once I get an, bn and a0, then we can directly substitute in the expression. Okay, so let me come to the main board. So we can check the value that we have got. Okay, yes, our value is minus 2 by n minus 1 raised to n. Okay, so answer is correct. So I can erase this. Okay, minus 2 by n minus 1 raised to n. Now we got this a0, an and bn that we can give in our Fourier series expansion. Okay, so f of x is equal to, so what's our Fourier series expansion? That is f of x is equal to a0 by 2 plus sigma n is equal to 1 to infinity an. What is our an? An is equal to 4 raised to minus 1 raised to n by n square cos nx. Okay, plus sigma n is equal to 1 to infinity bn. What is bn? Minus 2 by n minus 1 raised to n sin nx. Okay, so this is our Fourier series expansion. Now what is a0? A0 we solved just before, that is 2 pi square by 3, right? So if you substitute this a0, 2 pi square by 3, that is 2 and this 2 will cancel, so pi square by 3. So our f of x is x plus x square. Okay, that is equal to pi square by 3 plus, and here when you substitute, here you can take this 4 out. Okay, so when I am giving n is equal to 1, I will get minus cos x. Okay, n is equal to 1, I will get minus cos x. If I am giving n is equal to 2, I will get n is equal to 2, this term become positive, so 4 we have taken out, then 1 by 2 square cos 2x. And if I am giving n is equal to 3, I will get minus 1 by 3 square cos 3x plus etc. plus sigma n is equal to, here if I give n is equal to minus 1, okay, so I will get, that is minus sin x, right? I can take this minus 2 out. This is a minus 2 out, I can take out, as we have taken 4 out here. Okay, minus sin x plus 1 by 2 sin 2x minus 1 by 3 sin 3x etc. Okay, now we can do some values on either side. Suppose if I am taking x is equal to pi on both sides, what happens? Here pi plus pi square. Okay, pi plus pi square, and sin pi, sin 4 pi, sin n pi is 0. So this part will be completely 0. Then pi square by 3 is equal to 4 into cos pi is minus 1. So minus minus plus. So this 4 is out. 1 plus. This become 1 by 2 square. This become 1 by 3 square, because cos 3 pi is minus 1. So minus 1 into minus 1, that is plus 1 by 3 square. So all the term will be positive. Now if I replace x with minus pi, then here x become minus pi, and here minus pi whole square become pi square. Okay, so here I can give minus pi plus pi square is equal to pi square by 3 plus, okay, when I am giving minus pi, this whole part will be 0, as in the previous case sin n pi is 0, and if I am giving minus pi cos of minus theta again, that is cos theta, so we will get 1 again. Okay, So there is no change. We will get this expansion will cos of minus theta is cos theta. So cos pi and cos n pi is same value. Cos minus n pi has the same value. So 1 plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square. Now what I am going to do is I am going to add this. Okay, if I am adding this, what I get here, I have minus pi plus pi, that is equal to 0. Here we have 2 pi square. Okay, 2 pi square. 2 pi square, and here 2 pi square by 3. Here this term will double. That means 2 into 4 into this. That is 8 into 1 plus 1 by 2 square plus 1 by 3 square. Now here we have 2 pi square. Here we have 2 pi square by 3. That term we will take and simplify. Then we will have 4 pi square by 3. Okay, that is equal to 8 into this. Okay, now this I can cancel out this 4 and 8. Then we will have 2 here. That 2 I can bring here. So pi square by 6 is equal to, the remaining term is 1 plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square. Okay, now so this I can simply write as sigma n is equal to 1 to infinity 1 by n square. Okay, so this all about this section, and in the next section we will discuss about Fourier sine series and Fourier cosine series. Okay, thank you.